Over the past few years, various generative models have been proposed to solve the natural language to SQL problem. We propose a novel discriminative re-ranker to improve the performance of these models. The re-ranker extracts the best SQL query from the beam output predicted by the text-to SQL generator by leveraging a discriminator. Discriminators are relatively easier to train and have better accuracy because they need to model only the conditional probability distribution instead of the joint probability distribution that generators need. The discriminative re-ranker is a BERT fine-tuned classifier. It is trained as a binary classifier to predict whether a given candidate query obtained from beam search output of the text-to-SQL model is the gold query for a given utterance or not. First, we encode the utterance and the query using BERT. We take the last layer's hidden state for the first token as the input embedding for binary classification. The classifier is trained using binary cross entropy loss to produce maximum score for gold queries. We take the beam search candidates produced by a text-to-SQL model and sort them into an initial ranking by the generation probability of each candidate. We then predict scores for each candidate using the model. If the score of a candidate is substantially higher than the candidate above it in the original ranking, then that candidate is promoted to the higher rank. This allows the best candidate to bubble up through the list and become the top candidate. We modified GNN to leverage BERT embeddings, and we show that our approach improves logical form accuracy of a trained GNN model from 44.1% to 51.3%. We also show improvements in the performance of EditSQL. To conclude, our BERT-based discriminative approach significantly improves the performance of the text-to-SQL systems, making it practical to leverage generative approaches for building real-world applications. Thank you, and we look forward to your questions.